Okay, it looks like we are live. For those watching the YouTube video, hang out for a minute. We're going to do a little housekeeping while I post the link. Yeah, there we go. There we go. All right, got the link posted. Oh, here comes Stoyan.
Cool.
Hey, Stoyan, welcome. We're live on YouTube, by the way. Can you check your sound real quick, though? It says you're muted, but I don't see a microphone. Oh, there we go. It says you're muted.
He may just have not connected yet.
Can you say something?
Me?
Okay, yeah, okay, I can hear you.
I
Good.
didn't hear your first part, so I was thinking
Oh,
you're
okay.
talking to David.
Yeah, no, we're live on YouTube right now. Just heads up.
Okay.
So yeah, let's go ahead and kick this off. Let's do a round of introductions real quick. I'm Chris Troutner. I founded the PSF, and this is our technical steering committee meeting. David, you want to introduce yourself?
Sure, I'm out of place in this. I'm not a developer, I'm not a programmer. So, but I do work with Chris on business development for the Permissionless Software Foundation.
That's great. Stoyan, you want to give a little introduction about yourself?
Okay, my name is Stoyan Zhekov, and I am helping from time to time with the JavaScript BSH libraries.
Yeah, and since you're here, I want to talk about maybe moving forward with some grants for the NFT stuff. Let me go ahead and share the agenda. Stoyan, do you have anything specific you want to cover today? We could, depending on if it's a burning thing, we can cover it right now, or we can cover it after we go through the agenda.
No, I wanted to hear there was some interesting topics in the agenda. So yeah, we'll be happy to hear about the new stuff.
Okay, good. Yeah, let's dive into it. I actually have quite a few things to cover today. So these got added in sort of chronological order, so they don't have necessarily, we're going to jump around from several different topics, but just starting at the top, minimal SLP wallet, and I have a link to the GitHub repository right here. This is the front-end JavaScript library that's sort of the wallet engine behind wallet.fullstack.cache and message.fullstack.cache and chat.fullstack.cache. It's what controls the basic, wallet mnemonics, sending and receiving Bitcoin Cash, sending and receiving SLP tokens. It now uses the new utxo.get call that's been added to the BCHJS JavaScript library. And what's nice about this is it tees us up for work with NFTs, because you just make this one call, you give it an address, and it returns all the UTXOs associated with that address, hydrated with SLP token information if they're SLP tokens, and categorized into different arrays depending on whether that token is, whether it's like a type 1 SLP token or an NFT token or group token or a mint baton. Those UTXOs that represent those things will get dropped into their own little category array. And so this sets the web wallet up to handle NFTs really well. And we'll come back around to the NFTs, but I want to move on to the.
Will this reduce the rate limits problems? Like, is it still counting this one get call will be less intrusive than hydrating all of this with previous call?
That's a good question. I'm glad you asked that. So the approach that I've taken is that this is a really heavy API call in that you make the one call and then it sets off a chain reactions of server-side API calls. And so this is much more performant and faster. It returns much faster than the client making all those calls, because the server's making all those calls. But in order to keep it fair, all those internal API calls count against your rate limit. And so on wallet.fullstack.cache, because everybody's accessing the wallet from that one domain, I've just cranked the rate limits up for that domain. So people using the web wallet should not experience rate limits. But if you're building your own app and you're calling BCHJS or using minimal SLP wallet, it will count against your rate limits. So yes and no. And again, that's just really to keep things fair, so that people aren't penalized or unfairly penalized. If you're just making very low computationally heavy or low, in terms of computational heaviness, if you're making just like a call to the full node to get a transaction, that's really light, and that's one API call. Whereas like this one UTXO get call will set off a whole chain reaction that's very computationally heavy. So we need a way of sort of making that all fair. So that was the best I could come up with, was sort of tracking the internal API calls and having that count against your rate limit. But I also lowered the price of the 100 RPM tier at fullstack.cache, and I have added 2 additional tiers for these higher rate limits.
What about the people which want to use the full full stack.cache infrastructure only for fast BSH payments? They don't care about the tokens.
Well, yeah, that's a perfect example of what I'm talking about of fairness. In that situation, those API calls are really light because you're mostly just working with the full node and maybe the fulcrum indexer for looking up address balances and UTXO information. And so those would be very lightweight.
But they will
API
still
calls.
use the same call, right? Like UTXO get. And after this, they will process it somehow.
Right.
So it will be same heavy call again, but they will not care about the resulting NFT in the result, in the call result.
Yeah, that's a good point. So in that case, that get call, so if you're calling it on addresses that don't have tokens, it's not as heavy because it won't need to hydrate those, or the hydrate call will come back very quickly saying like, I haven't detected any tokens that I suspect are SLP
will
tokens.
be like better, for example, to add a small flag in the parameters when you get request, but you only care for BSH. And it will return non-hydrated stuff immediately without doing the calls at all to getting tokens.
Yeah, so what you got to be careful about, if you're in the case of where you're a wallet developer and you don't care about tokens, you just want to use BCH, you still have to be careful that you don't burn tokens. And so one way you can do that is with minimal SLP wallet is like, if you do hit a rate limit, any UTXOs will get thrown into this, like there's a null category where it's like, for whatever reason this UTXO couldn't be validated. It could be an SLP token, but maybe you hit your rate limits or maybe something else happened. And so those go into this null array. It's an array of just unvalidated tokens. So that makes it easy for a wallet developer to basically just ignore that array, and that way they can be sure that they're not at risk of burning a token. So that's a possibility. This is where, like, depending on a wallet developer, like they have options. They could just use the straight up BCHJS library and do these, like they can either use the UTXO get call, but then if they want to optimize from there, that call is really just a combination of lower level calls that are also available in BCHJS. So it's possible to, depending on how the developer wants to do it, I think the different ways in which they want to optimize, it's totally possible to basically get all the UTXOs back from Electromex, and then scan each one for an op return, and then basically ignore the ones that have an op return, or have an op return that looks like an SLP token without actually making a call to SLPDB to hydrate it, which is the more expensive operation. So that would be one way to do it. I see your point, and that it's like when you try to make these high level convenience calls, you can't please everybody. You got to make a trade off.
On the Telegram groups, there was several like calls for the BSH as a service, and the full stack.cash was mentioned as a possible solution. But because now there's still a lot of fuzz about this around these tokens, so will be there SLP, or there was several another proposals. So some of the wallets, they just care for fast BSH payments still. So I was just thinking, okay, can these people still use the same infrastructure provided by a full stack cache? But yeah,
they definitely can. And if there was a big interest in this, of like, hey, we want fast, low, not heavy API calls, it's just BCH, I could create another endpoint that could service that need. It's definitely possible. I mean, the real trick there for everyone is, if you don't care about tokens, is just not burning tokens. You need to be able to safely spend BCH without burning tokens. And so that's the real problem that needs to be solved there. And we definitely have ways of solving that problem. And if there's a big interest in the community, we could always create another endpoint that caters specifically to that use case. Good question, Stoyan. And good feedback. I know there's a lot of talk going on around the tokens. We've got group, and we've got the V3 transaction format, both of which could do minor validated tokens. And I've actually been following Bitcoin Autist. He's got a, what is that, Zoom channel, SLP 2.0, and he's been doing a lot of good work in terms of just really analyzing the two proposals. And I think he has a third proposal, which is a hybrid of the two, and that's starting to gain traction.
Okay.
So it'll be interesting to see how that plays out.
Okay.
There we go. Okay, so that's this one. So yeah, basically the takeaway from that is that wallet.fullstack.cache is teed up really nicely to start doing NFT plugins. There's one, I guess this is probably a good time to diverge onto this. So Stoyan, you and I have talked about doing better NFT plugins for the wallet app. And the outstanding item, which is on my to-do list, is to pull out these SLPDB queries in some of the code that you've given me, that you've created, and make new REST API endpoints that can essentially, you can give it a group token, and it will give you all of the all of the NFTs that have been created from that group token, or the opposite, give it an NFT and it'll tell you the group token that it came from. And so now that we have this the slush fund for bounties that's been approved, we have funds for that. So I'm thinking about just rolling that into a bounty to have you create those REST API endpoints, since it's taking me forever. And then that's everything we need to start creating plugins for wallet.fullstack.cache that can nicely display NFTs. So if that's of interest to you, let's talk about that offline, and we'll work on getting a bounty together and put a scope of work together for that work. Because I think you're perfectly positioned to do it. You understand everything that's going on, and I'm tired of holding you back.
Yeah, it's good to have some progress. I made some open source like viewer. It's a ready React component named NFT card. So you can just put this inside the wallet and it will display the NFTs even now.
Oh, cool. Cool.
It does not depend from PSH, GS or SLP, GS, whatever. It's just REST codes.
Oh,
So
cool.
it will work even now with any wallet.
Oh, wow. Boy, I'd love to see a demo,
Yeah,
or at
it's
least some
working
screenshots.
site. I will.
Yeah, let me.
it's-
There, you should be able to share your screen if you want.
I will send you the URL maybe now or like.
Yeah, now's as good a time as any.
So this are the sources here, and I just put it in this Zoom chat.
Mm-hmm.
And the working site is deployed here.
Okay, NFT checker.
And I deployed it on Heroku.
Oh,
It's have a little specific element inside because it's also checking if this token can be traded on this jungle
oh, okay.
popular recently. So if you just put here your token ID, it will show you information about this token.
Okay, so if we go to like jungle, is it jungle.net? Is that it?
Yeah, I just
Maybe
you can try.
There we go.
You can try directly this URL. But yeah, just click on this thing.
Yeah, I'm just trying to get to the
Very nice, Tyler.
the TXID here.
Yeah, I've got one up on my screen right now.
I can't seem to.
If you click on the URL that I put in the chat, it's a little interesting token.
Oh, okay. Oh, okay. Here we go.
Share the dragon girl with us, Chris.
There we go. Cool. Okay, so it gives you an IPFS hash.
Because yeah, what is interesting, this is using the BCP payload. If you see this red document URL, if you copy this is the transaction, in fact, transaction ID.
Okay.
So if you put it in the explorer.bitcoin.com, you will see the op return with the information about this token.
Yeah, let's go try that. Oh. Let's see.
Maybe
I don't see.
Just click on the token info, maybe. Yeah.
Token info. Okay.
And then you can maybe copy this document URL.
Yeah, there we go.
Yeah, no, the
the document URI.
Yeah.
Oh, very cool. Okay, so you put the transaction.
Yeah, you
in
can
the
see
document
here,
URI.
Yeah, if you click on the view details, maybe first.
Yeah, this thing's constantly
If you click
changing.
on this op return, you can see it's
yeah, there's BCP.
And this 3 and 4, what kind of token is this? So this is the image token.
Oh.
And 4 is, I think, for the IPFS.
Okay.
The rest of the stuff is just encoded this QM hash.
Cool. I'm gonna pull up your library on npm just so people know what we're talking about. It's BCP JS.
Yes.
And so this is a tool that you developed for analyzing NFTs on the Bitcoin Cash chain. And and you have these types, like different types of media formats. So you're saying that 4 is IPFS.
Yes, and the 3 is image, I think.
Is an image, yeah.
because it can be, for example, there's another cool case, which is a monkey video. I'll try to like this one. So how to see, because this BSP standard format, it's very easy for the viewer to display these kind of files.
Mm-hmm.
Click on this one, for example.
Oh wow.
Nice. So you've got an embedded video.
Yeah.
Man, that is great.
Because the viewer can get this document URI, and it can parse it and see that this is the video on IPFS, so it
Right.
can display the media immediately.
So you create the NFT, and in the document URI, you give it a transaction ID for a separate Bitcoin Cash transaction, and the operator in that transaction gets the BCP information. And so the site that you're building unwinds that whole breadcrumb trail and displays the media, displays all the information. Man, this is great.
Yeah, and also this NFT checker, it's supporting not only such kind of BCP, but it's also supporting the current this waifu stuff, and it will show all of them.
Yeah.
So it can be used, and this is the separate like React component, this cart. So with a little tuning, it can be used directly in the wallets.
Yeah.
The only parameter is the token ID. You get it from somewhere, send it to this component, and it will show you.
That's cool. So yeah, I would love to take this work that you've done and add it as a plugin for wallet.fullstack, or like we'd probably create like nft.fullstack.cash, and it would be like a wallet dedicated for, you know, NFTs for just having a really good NFT experience for browsing and pulling up information and have it right there in the wallet. Because that's what this app is sort of lacking, right? Like if you own this NFT, you can't like send it to someone or so it'd be great to combine this functionality with wallet functionality.
Yes.
Great work, Stoyan.
Yeah. So
that
with help with this Getco, we can continue to make this better and better.
Yeah. Okay, so going back to the agenda. So that's cool. So that's, we're cooking along on the NFT front. So that's great to see, because I think the bubblishness of NFTs is starting to decline. I don't know. That's just a gut feeling. I could be wrong about that, but I think that enough people have been impressed with NFT tech that it's here to stay. And it's just like in 2017. I'm so reminded of 2017 at this point, where there was like this mania in price, but there was this undercurrent of like steady development that happened like before the price spike and after the price spike. And I think that's where we're at, like with the NFTs, is we're just like steadily working on it, and we're not going to get it done in time to you know, keep the hype going. So there's probably going to be a crash in prices with regard to NFTs, but we'll just keep building. And
yeah, because how to see, the price is falling because they still not good NFTs.
Yeah.
People start to figure that they don't want to pay so much just for an image.
Right. Yeah. No one like that. It's so hard to get a conversation going about like, oh, where's the payload for your NFT backed up? Like, will you be able to access it in 10 years?
Yeah. So maybe the how to see, the techniques will improve, so the price also will start going up when there is good NFTs.
Yeah. I've been following. I'm really encouraged to see the emphasis on storing the NFT payload data in IPFS. IPFS has really been. They've got a bunch of blog posts, and they've been rolling out tools. I mean, they're focused more on the Ethereum side of things, but they've got a lot of tools for creating NFTs, putting the payload on IPFS, backing the payload up on Filecoin. And I haven't really had a chance to dive into it, but it's very complementary to the work I see you doing.
They will even soon have some seminar, I think, this week or next one, especially about the NFTs
Yeah,
on IPFS. So I will try to
saw that as well.
listen what they have new there, because yeah, it's interesting.
Yeah, well, yeah, that'd be good. I mean, because I think that would really complement the work you're doing, and then I would
Yeah,
love for
I think
you
in
to
the agenda
teach me.
you also have something about the IPFS. So
Yeah. Let's get back to that. Yeah, so we'll get there. Okay, so next thing on the agenda here is BCHJS, similar to the improvement we made with UTXO.get. We created this transaction.get call. So if people want to pull up this documentation, it's at bchjs.fullstack.cache. But basically, you can give it. I should have come up with an example of what you get for the output. But if you look at a transaction on the Block Explorer, yeah, that's what we're doing right here. You'll see that there's inputs on the left and outputs on the right. And what this call will give you is the same information that you'd get. It starts with the same transaction information you get from a full node. But on a full node, on the inputs, there's not going to be any addresses or value in terms of like how much Bitcoin Cash was in. It'll only show you addresses and Bitcoin on the outputs. So what this call does is it sort of does that backwards work to figure out what were the input addresses and the input amounts. So you have them both on the inputs and the outputs, but then it goes one step further and it hydrates the inputs and outputs with token information. So very similar to whereas like explorer.bitcoin.com, it presents this information graphically. This will give you like a JSON payload that contains all that information. So it's the same sort of transaction format that everybody's been getting for years from a full node, just with this extra information added to it. So it's pretty handy. This is like the core piece. This, basically, anybody could build a block explorer like explorer.bitcoin.com now with just this call, because you just have to make the one call on the transaction and you have everything you need to display it on the front end, and you don't need to do any extra work. So that's the main value behind this this change. Yeah, transaction history, block explored. Yeah, the other main use case for this call is wallet transaction history. I think this is going to get incorporated. I was hoping Joey would be here today so he could confirm this, but I believe this is getting incorporated in Cache Tab, so that he can, so that your wallet can easily display. And we'll probably roll this into a plugin for wallet.fullstack.cache too. Now that we can easily display like your transaction history, and you can click on the transaction in your history and then get this kind of detail, like was this tokens and how many tokens and how much Bitcoin Cash and what addresses were involved. It answers all these questions. Okay, so that was that one. Moving on, BCH API PR128 removes a bug. This is a bug that Joey discovered and fixed yesterday. And so it turned out that there was, I don't know how it got in there. I don't know if I put it in there or if it's just some legacy code that carried over from the Bitcoin.com REST that the BCH API was forked from. But there was a call in there that would reset the big number to only work with 8 decimal places. So if you had an SLP token that was like 9 decimal places or bigger, it would truncate it, and it would result in like you burn those tiny fractions of your token. And anyways, so that was a problem. Joey found it and he fixed it. It was a 1-line fix. So that's just worth mentioning. So these next 3 are things that I've been personally working on and I'm a little passionate about. I have a link here to my blog where I talk about IPFS service providers, and there's a video. There's actually I want to point out 3 blog posts. This is actually like a series of blog posts of research that I've been working on where it starts talking about IPFS APIs, and then I introduce chat.fullstack.cache, and then this latest blog post is about these IPFS service providers. And each blog post has a video or two to accompany it. But basically, let me actually see if I can just give a demo real quick. Oops, not that one. Hopefully this doesn't kill my internet connection because there was a bug. But I'll give it a second to spin up here. But basically, this is a single page app that is connecting to the interplanetary file system, and it's currently right now it's going out there and it's looking for other computers that are subscribed to this pub sub channel or this app that it can communicate with. It should find the example service provider here pretty soon. And basically, what this JSON RPC is it's a replacement for a REST API, and they do the same thing. That's basically just a way for two computers to talk to one another and exchange data. The difference is that the REST API, which is the way the internet works, today, is location based. And so if a state actor or a corporate actor wants to prevent you from accessing something, they just block that location where the data is, and it's easy and it's done. And so it's just very easy to censor people from content on the internet that way. And so IPFS is really good at jumping over firewalls. And the whole point of chat.fullstack.cache was to, let me just check my network. Okay, I think it's being well behaved. Okay, there we go. There we go. We just found the service, the peer here. So that's another peer here on the IPFS network. This is basically a chat room, and you can chat with people. And once you have chat, you then have everything that you need for a JSON RPC. I think it's 2.0. And then I think I can do method about. I think that's all I need to do. Oh, and then I need an ID. We'll see if I got that right. But if I got it right, it should respond. Maybe I didn't get it right. But if I go list peers, these are all the peers I'm connected to. And I can find the one that I'm connected to. These are IPFS handles for people who aren't familiar with them. And so I just asked basically it about itself. I'm going over this really fast because there's people who are interested in this can do the blog posts, but I just wanted to give an example of a JSON RPC. So here's an example of a JSON RPC command. So if I go here, and I'm not sure what I typed in wrong. It should, there we go. Now it responded. So I just sent it a command and it responded with some data. And we've already got these CRUD endpoints where you can create a user, update a user, get users, delete a user. So you can create a user, get JOT tokens. So this is a way of providing services, computational services over IPFS. So like, for example, wallet.fullstack.cache, I always go back to this sort of canonical use case where this lady in China wanted to use it, but it was blocked. Now she'll be able to use it with this technology because IPFS will be able to tunnel through the firewall of China. And you can also achieve this sort of federated system. So rather than everyone needing to connect to fullstack.cache, anyone can provide those web services that fullstack.cache provides, like full node access and indexer access. And so a web app using this technology, it only needs to find someone on the network that can provide the services it needs. It doesn't need any specific provider. So this whole idea of providing blockchain services, like access to a blockchain, either for reading or writing or indexers, anybody can throw up a service provider and provide those services over JSON RPC. And anyone in the world can consume those services. and it will be in a way that's private because all this communication's end-to-end encrypted using Bitcoin elliptic curve cryptography. Same encryption that's behind the way you spend money with Bitcoin is the thing doing the end-to-end encryption. And yeah, and so it's really powerful because now we can have both a decentralization on the provider side and this sort of robust censorship resistance on the consumer side. So I'm pretty excited about this. I think this is a big deal. So anyways, I'll refer people to the blog post if they want to get more information, and I'm always happy to discuss it in deeper detail. But there is a book that Bill Gates wrote. I'm blanking on the title, but he talked about how they bet the company, Microsoft, they bet the company on the internet in the early 2000s. And they basically put all their resources and pivoted, even though it was a painful decision because it was eating their legacy product. And I feel the same way about this JSON RPC. Is I've spent a lot of time building the REST API behind fullstack.cache because it's a needed service, but this JSON RPC idea is such a powerful idea that I'm willing to bet big on it. And I think that this federated approach is just a better design. It's a better architecture. It's much more robust, much more censorship resistant, and the federated the way that it can tap into sort of a federated model is just generally good for cryptocurrency. So just moving through the agenda, a related idea that I'm going to start working on next is this pay to write database. I talk about this in this blog post as well. So in this application, when my node, which is in this web browser, is talking to this other node, it's going over IPFS, but there's this database called OrbitDB. And so these messages, these encrypted messages, they're actually getting stashed in the OrbitDB. And what this does is it prevents dropped messages. So if my full node, if it's not a full node, if my browser was to go offline for a short period of time, like 10 or 15 seconds, which happens a lot in the IPFS network, when it comes back, it'll get any messages that happened while it was gone. And so the same OrbitDB tech, I've been digging into it, and there's a way to the write access for the database. I've successfully built a prototype where anyone can write to the database, but in order to do so, you have to prove that you've burned an SLP token, and you use the transaction ID on the blockchain as your proof. And then each node that's replicating the database will independently verify that this new entry into the database meets this rule, and only after it's been independently verified will that node accept it into the database. And so it's very similar to a blockchain in that regard, except there's no mining. And I think I'm really attracted to this because there's this it's such a clear and straightforward incentive model where if we build software around these pay to write databases, our token, because someone would have, like, it's like, oh yeah, anybody can write. So let me just give an example so it's not so highfalutin. Torlist.cache is one idea I want to use this for. I also want to use this for a decentralized exchange, and I think it's a little more straightforward with this idea of a decentralized exchange where Stoyan, let's say you have some SLP tokens that you want to sell. So you'll find a service provider using this JSON RPC that is running one of these databases so that you don't have to do it yourself, or you can do it yourself. Either way, it doesn't matter. But in order to get your sell order, like let's say you want to sell some SLP tokens, in order to get your sell order into the database, you have to burn some PSF tokens, and then that sell order will go into the database. And then everybody who is syncing their own local copy of this database gets that data. They can share that data. Anyone can fulfill that order. and trade with you on a peer-to-peer basis. And we can try, and the PSF is incentivized to build a good user experience around this whole thing, because our token becomes directly more valuable through the usage of this database. So the better we can make the user experience, we directly benefit, because in order to use it, you have to burn our token, which causes the price to go up. So the incentive mechanisms are just very clear and very straightforward. I'm really attracted to it from that perspective. And then there's all sorts of things you can do, because this database is inherently decentralized and thus censorship resistant. So I'm really excited to explore this idea going forward. I think, again, this is an incredibly powerful idea.
How this I don't know much about this Orbit DB, but how is it better than, for example, keeping my order like a JSON file with this Bitcoin file protocol directly on the blockchain?
Yeah, that's a good question. So it's that question that led me down the road to this conclusion, because the thing about opportune data on the blockchain is the incentives are not aligned, and it's a scaling problem. Like right now we're doing fine, but I've been in a lot of Bitcoin Cash developer meetings where I've like posed this question, where like, what if we 1000x'd the transaction volume from where we are today? So we're around, I think, 300,000 transactions a day. So if we started doing 300 million transactions a day, SLP tokens would not work at all. Like basically everything that involves op return data would not work, because the chain would get so big so fast that we'd have these massive scaling issues. And there's also this incentive misalignment where you pay to write that data to the chain once, but then everyone from then on has to bear that burden, and you do not pay to retrieve the data. And so in this world of very high transaction volume, I believe everything's going to run as a pruned node. That's the only way it can run at that level of scale, which means all that op return data is going to get thrown away. And I mean, it'll still be part of the block, and there still will be archival nodes, because it will need to be archival nodes so that new nodes can sync. But in that situation, op return basically has to go away, or at least being able to look more than like, say, 10 blocks back in history at op return data, that's going to have to go away. So this is this is a far off issue, but we're going to hit it. If the trends continue and we're successful collectively with cryptocurrency, we are going to have this issue in the future. And so this is one way of moving data off chain, and being able to pay for it. And then you can align incentives better with like this retrieval market, being able to pay both to store and retrieve data. And so right now, today, yes, you could just put your data in an op return and that works fine. But there's going to be a reckoning at some point in the future where that's not going to work so well.
Is this Orbit DB like kind of a relational database or document storage? How is this working?
It's actually at its core, it's an append only log, because it works on IPFS, and IPFS is all about immutable data. So it's this append only log. So that's like the core idea. But then Orbit DB is super flexible. It can be a key value store. It can be like a Mongo database where you have like a document store. They've got like logs and feeds, and they have like 5 different flavors of this database. But all at their core, they're these append only logs. And so one of the caveats when working with this database is there's no way to delete anything, because it's immutable and it's append only. So when you delete things, you're like deleting them. You're just marking them as deleted, but it doesn't actually cause the size of the database to decrease. And so that's one of the challenges of working with this type of a database is The solution to that is just to abandon the database and create a new database. And so that's what chat.fullstack.cache does. In order, it uses OrbitDB to prevent these dropped calls. But we don't want the databases to get too big. So every hour we abandon the database and create a new one, or every user does that. And that keeps the databases really small, but it still achieves the goal, which is to prevent dropped calls or dropped messages. So yeah, it's a whole nother tech. Like a lot of there's, I've had some time to wrap my head around this. But yeah, there's a whole nother tech, but in essence, the broad strokes is that it's a peer-to-peer database. So everyone maintains their own independent copy of the database. The write permissions get sort of baked in for the very first person who creates the very first instance of the database. Those write rules get baked into it, and they're immutable at that point. If anybody tries to mess with them, they'll end up just creating a different database, so they won't be part of that database. And then it's immutable and append only. So that's another like thing to keep in mind.
Okay.
So yeah, so this is just in the idea phase right now, but I'm glad we had a moment to explore it. And if anybody watches this video later and they want to know more about it or are interested in exploring it, I welcome them to join the PSF Telegram chat room. But this is going to be these two ideas, the JSON RPC over IPFS and this pay-to-write database. These are two ideas I'm very fired up about. I've done enough research to know that to essentially eliminate the technical risk. Like these are possible. I have working proof of concept. So now it's a matter of, okay, how can we make money with this thing? How can we what are these valuable business solutions that we can build with this new tech? So that's where I'm at with these two things. The final thing on the agenda to bring up is this Avalanche SLP token bridge. This is coming up pretty soon. There's nothing really to show, but Don Wanton, who is a frequent member of our community committee, he's been funding the development of this token bridge, and we've got the one way of the bridge working where you can send a token from the Avalanche side to the Bitcoin Cash side, and we're currently wrapping up the other side of from the Bitcoin Cash to the SLP side. That'll be wrapped up here in the next week, and then what we're going to do is fork SLP Cli wallet, which is our sort of command line based wallet, HD wallet on Bitcoin Cash for working with SLP tokens. We're going to fork that, make a version of it that works on the Avalanche side, and then we'll bake in these commands. And that'll be our main development tool and testing tool. And then we'll roll them into a graphical user interface from there. So probably in the next month, we'll have functioning web wallets on both chains. And it won't work. Again, I have to always emphasize it. This won't work for every SLP token. This will only work for specific tokens. So what we'll do to roll this out and let people play with it is we'll have a token faucet on both chains. So you can just go get free tokens and then practice sending them back and forth just to learn and there's also, since this is a technical meeting, I might as well get into a little bit of the technical nuance. The way this works on a technical standpoint is on the Bitcoin Cash side, there's two transactions, and the Avalanche side is actually a lot more straightforward. The Bitcoin Cash side, in order to send a token to the Avalanche side, what you need to do is create two transactions. So you create a transaction to send your token to the bridge, but you don't broadcast it. You generate it in order to get the transaction ID ahead of time without broadcasting it. Then you create a second transaction with an op return, similar to how you do it, Stoyan, with the BCP, where you'll send a dust transaction to the token bridge saying, with the op return data being, here's the transaction ID that I want you to look for, and here's the address on the Avalanche side I want you to send the tokens to. And then after the bridge receives that transaction, it knows what to look for. Then you can safely send the tokens to the bridge. where it will then receive the tokens, burn them, mint them on the Avalanche side, and send them to the address that you specified in the op return. And if you don't do that, its default behavior will be to just send the tokens back to you. If it doesn't know what to do with the tokens, it'll just send them back to the originating address. On the Avalanche side, it's everything can happen with one transaction, and there's no confirmation time, like block confirmation time, like there is in Bitcoin Cash. It's like 1 second for finality on there. And so in Avalanche, it's possible to send a token, and there's a memo field where you can specify where on the Bitcoin Cash side you want the tokens to appear. And so then the token liquidity bridge does, or this token bridge does the same thing, where it'll burn the tokens on the Avalanche side, mint them on the Bitcoin Cash side, and then send them to the address that you specified. So that's how the bridge will work. So I'm pretty excited. It's a fairly complex piece of machinery, but it's coming along pretty well, and we're just a couple weeks away from having something that people can play with. So that's the agenda. That's what I wanted to cover today. David, Stoyan, do you guys have anything else you guys want to cover?
No, lots of good stuff going on. It's great to see it.
Yeah, it's so many information.
Yeah.
I need to think a little before asking questions.
Yeah, I think part of the reason why there's so much info here is because we missed I wasn't able to host the last technical meeting, so we got like a month worth of things in this meeting. But yeah, so hopefully in 2 weeks when we have our next technical meeting, I'm hoping by then we'll have at least some sort of command line script to run to exercise the bridge. So that'll be a lot of fun.
Why you decided to fork this client wallet? It's make more sense to maybe patch the minimal SOP wallet, because it can also after this be put inside this wallet.fullstack.cash.
I think we're going to do both because the SLP client, and really what I need to do is integrate minimal SLP wallet into SLP Cli wallet so that we're just using one wallet engine library, and we'll probably do that as a result of this. So SLP Cli wallet was built like a year or two before minimal SLP wallet, and it's this sort of interactive command line tool for rapidly prototyping Bitcoin Cash transactions. Minimal SLP wallet was developed just a few months ago, and it's really intended to be a front end library for web browsers to add. So it's not intended to be interactive like SLP Cli wallet is. And so I've actually been slowly converging the two libraries together so that SLP Cli wallet would use minimal SLP wallet under the hood, just like wallet.fullstack.cash uses. I'd love to get to that point where we just have the one wallet engine for everything. So hopefully that's how the trend will continue to play out. But good question though. Yeah. Okay, guys. Well, I think we can wrap that up. Yep. Stoyan, I really appreciate you staying up and making time for this. You always bring really good questions, and I'm always interested to see what you're working on. Let's get together offline and talk about putting together a grant if you're interested in doing some I think those endpoints for REST are valuable just on their own, and then if we do that, I think it would also be great to see some NFT plugins for wallet.fullstack.cash.
Sure.
Yeah. Okay.
Yeah. Okay.
Thanks, guys.
Cheers, guys.
See you. Have a great night, day.
Yeah.